Hello, science family. Today we're looking into our Quiz 1 review on atomic structure. Let's get down to business and start kind of relating everything between protons, neutrons, electrons, atomic number, mass number, isotopes. Let's put it all together. So if we start with number 1 here, you'll notice that this nitrogen has a 3- charge, so a -3 charge. If you remember us learning, charge for any ion, right, is going to always equal the protons minus the electrons. All right, so we'll have to keep that in mind when we figure out different things and what the charges are. All right, so first thing for nitrogen here, it doesn't matter what charge it has, its number of protons doesn't change. So if you look at nitrogen on the periodic table, you'll find that nitrogen is element number 7. So that means it has 7 protons. Let's actually go down the list here. Strontium, if you look on the periodic table, strontium is going to be element 38 on the periodic table. So notice, even though there is a charge on these guys, like iron has a 2+ charge, for protons, that doesn't matter. It's only the number on the periodic table. So iron is element 26. And if I look at bromine on the periodic table, I find it on the periodic table, its atomic number is 35. All right, now that I have that, I can start to figure out my electrons. All right, well, how do I do that? Well, if nitrogen here is a -3 charge, and I remember that it's protons minus electrons give me the charge, then I can figure out how many electrons I have. Let me plug it into my equation. So if the charge is -3 for nitrogen, and according to my research already, nitrogen is 7, 7 minus x is going to give me a -3 charge. So how many electrons does there have to be in order to have a -3 charge? There's going to have to be 10. Because remember, 7 minus 10 will give us that -3 charge overall. All right? Here's another way to think about it. Let's do a little side note here. Say there's 1, 2, 3, 4, 5, 6, 7 protons in nitrogen. All right? And so let's say there are 10 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. All right. The question is, why is it a -3 charge overall when you gain electrons? Why does it get negative? Well, remember that a proton and electron cancel out. So for every proton, an electron's charge cancels out. So let's start canceling out a proton for every electron. Proton, electron, proton, electron, proton, electron. And take a look what's left. After all the protons and electrons have been canceled out, you still have 3 electrons left. Well, if each electron has a -1 charge, -1, -1, and -1 overall make a -3 charge. So that's why when you take the protons minus the electrons, if you have more electrons, you end up with a negative charge. So let's figure out the rest of this then. If it is a -3 charge, we know negative charged ions are called anions. So this would be an anion. Now that we figured that out, let's go on to strontium. Next is strontium. Strontium we know has 38 protons, but it has a +2 charge. So that means 38 minus what would give us a +2 charge overall, because the charge equals the protons minus electrons. So 38 minus 36 would give us that +2 charge. So there must be only 36 electrons. That makes sense. Since there's 2 more protons than electrons, there's an overall +2 charge. By the way, if it's a +2 charge, any positive ion is called a cation. If we look at our next problem, iron has 26 protons, and it has an overall +2 charge. That means we have to have 2 more protons than electrons. So you should only have 24 electrons. Double check, just plug it into your equation. If the charge on iron is +2 and you have 26 protons, 26 minus what gives you a +2 charge? It's got to be that 24. And since it's positively charged, we're going to call that a cation. For bromine, bromine is element 35. It has a -1 charge overall. So that means if it's a -1, it has to have one more electron than proton. So that's why it's going to have 36 electrons. And remember, if you do 35 protons minus 36 electrons, overall that gives you a -1 charge. So that's why there should be 36 electrons. If it's a negative charge, by the way, we know we call that an anion. Now for question number 2, it says if an atom becomes negatively charged, does it gain or lose an electron? Okay, so if we're going to have a negatively charged ion, that means you have to have more electrons than protons. So you are definitely going to gain an electron. Now, why? Explain. Now, you should write this down. I'm not going to write it down, but you write it down in your own words. But the reason, when you gain electrons, you gain negative charge. So now you have more electrons than protons, so it becomes negative overall. Go ahead and write that down in your own words. For question number 3, if an atom becomes positively charged, does it gain or lose an electron? If it's going to be positively charged, you have to lose an electron. Now that throws people off at first because they think, wait, how am I losing but becoming positively charged? Well, if you lose an electron, you now have more protons than electrons, so that makes you positively charged. So for your explanation, write down in your own words what I've just explained. The fact that when you lose electrons, you now have more protons than electrons, so you have more positive charge. That's why you have to lose an electron. Remember, you can't lose a proton. If you lose a proton or gain a proton, you're going to change elements. So only the electrons are the things that are going to move. For question number 4, what determines the identity of an element? So what? Protons, neutrons, or electrons are always going to stay constant and tell you exactly what element it is. That's going to be the protons. The protons tell you the identity of the element. So if I say element number 6, you look on the periodic table and say, oh, that's carbon. Only carbon can have 6 protons. If I say element number 30, that's going to be zinc, Zn. Oh, only zinc can have 30 protons. So protons is exactly what tells you what element. So make sure you explain in your own words what we just talked about. For number 5, 2 things that must be equal for the atom to be neutral. Well, if we remember, charge is equal to protons minus electrons. So if protons are positively charged and electrons are negatively charged, you have to have your protons and your electrons equal. Remember, neutrons are neutral, so they don't really have a charge. They don't matter in this situation where we look at what's going to be neutral. So your protons have to equal your electrons. And if they're equal, they'll be neutral. When looking at question number 6, we're trying to fill in the rest of the chart. It does look like we're looking at the mass, charge, and location of an atom for the different particles. Okay, so let's take a look at that and see what we can figure out. Well, if we look under the mass category, something is about the same as a proton. Something that's about the same mass as a proton, I would say, is a neutron. So now we know that the second row is going to have neutron. If we look then, the only thing that's really left here is the next column, which is going to be, or I should say the next row, which is going to be the electron. So let's get the electron in there too. Now that we know we have proton, neutron, electron, let's start filling out the different things. For mass, if you look for proton, the mass of proton is really similar to the mass of a neutron. So we didn't really memorize how massive a neutron is, but we are trying to say, though, that the protons and neutrons have about the same mass. All right. If you remember from our notes, though, we're assuming that electrons have no mass. So the idea that we're just ignoring them. Now remember, electrons technically do have a little bit of mass, but it's so small for this level of chem, we ignore it. All right, let's look at protons charge. We know that the proton's charge is going to be a +1, right? That's something we learned one of our very first days. Then if we look at electron, we know electron has a charge of -1. And we've known that for quite a while from our first days of notes. So protons +1, neutrons 0, no charge or neutral, and electrons a -1 charge. Now, location for protons and neutrons, it's the same. The protons and neutrons are inside the nucleus, right? This is where all the mass of the atom really comes from. Outside of the nucleus, we know, are the electrons. They're the ones with high energy that are outside, attracted to the center of the atom, but never touching the nucleus center of the atom. They're just on the outside. But this is a great table kind of comparing everything we've learned and talked about. So all these pieces of information are important. You want to make sure that you understand all of them. Number 7 is a great question that people often get confused about. What is the difference between mass number and the average atomic mass? Remember, the mass number is just going to be, for that isotope, protons plus neutrons. But the average atomic mass is the mass found on the periodic table. So it's found on the P table, the periodic table. And remember, just like it says, it's the average of all the different isotopes. So when you're writing down your answer, make sure that you put how average atomic mass is really taking the average of all the different isotope mass numbers. That's important and something that people often goof up or overlook. Now, for number 8, we've already done this, but a good recap. What is the equation for finding the charge an atom has? Remember, the charge is going to be equal to what? Think about it. It's going to be the protons minus the neutrons. As long as you feel good with that, we should be all good. Charge is going to equal protons minus the neutrons. As we move on to our second page here, we have a little bit of a repetitive question because we already discussed it earlier. But what's the equation to find the mass number? Remember, our mass number is just simply going to look at an isotope, and it's going to be the protons plus the neutrons. Simple as that. As long as you can add those up, they'll be good. Speaking of that, we bring us to number 10, which brings all of this together, this whole chart of comparing atomic number, mass number, etc. So this is a great thing for us to practice with. Taking a look here, let's start with the very first row. So we know that this object has 30 protons, and we know that atomic number and protons are equal. So that's good. We know if we have 30 protons, we have a 30 atomic number. We also know that we're assuming all of these are neutral. So that means we're assuming that there's also 30 electrons to cancel out the 30 protons. Now that we have that information, we can figure out the mass number. Remember, the mass number is just going to be equal to protons plus neutrons. So if I add up 30 plus 27, I'm going to end up with 57 for my answer. Nice. Now that we figured all that out, we can start naming this object. Since the atomic number is 30, I'm going to look on the periodic table to find element 30. Element 30 on the periodic table is zinc. And when I write its name, I'm going to write zinc with its mass number after it of 57. Because that's its isotope name, I want to be specific about its name and its mass number. To write its symbol, it's simple. I'm just going to write Zn for zinc, but don't forget I'm going to include 2 numbers. The numbers I'm going to include are the mass number on top, 57, and on the bottom I'm going to include 30 for its atomic number. Now that I did that, I have all the information out there about this specific isotope, zinc 57. Now, if you look on the periodic table, you might say, well, Mr. J, zinc is 65 for its mass on the periodic table. What is this 57? Well, this is a specific isotope of zinc, 57. But the average mass for zinc of all the isotopes is 65.39. So remember, on the periodic table, that's an average of all the different isotopes, not just individual ones. Let's jump to the next row, iron 56. Okay, first of all, the fact that it has 56 in it means that's its mass number, 56. If I look for iron on the periodic table, Fe, I figure out that it's element 26. So right away, that tells me the atomic number is 26, the protons are 26, and I can assume that the electrons, there's 26. Now, for the symbol, iron on the periodic table is Fe, so I'm going to use that. And I know that my mass number is 56 on top, and the atomic number on the bottom is 26. So that's how I'll write my iron, Fe, 56 over 26. The only thing left to do is figure out the number of neutrons, all right? To do that, don't forget, the mass number is equal to protons plus neutrons. So the question is, what plus 26 gives you 56? 30. So you're going to need 30 neutrons to add to the 26 protons to give you the mass number of 56. Some of you might have done that differently. You may have taken 56 and subtracted 26 from it to give you 30. Totally fine. Another way you could do that as well is take your top number and minus the bottom number in your symbol right here. 56 minus 26 gives you 30. That could also help as well so that you could figure out how many neutrons there are. If we take a look at the next row, we know we have a mass number of 107, and we know we have 47 protons. Well, if I have 47 protons, I have the same for the atomic number, it's 47, and I can assume that I have the same number of electrons to keep it neutral. If I look on the periodic table, element 47 is silver. So now I know that my element is silver, and since I know its mass number, I'm going to put 107 afterwards, silver 107. Now, from the periodic table, I know silver is Ag, so I can use that for my symbol. I'm going to put the mass number on top and the atomic number on the bottom, 107 over 47. The only thing left to do is figure out how many neutrons, just like we did in the last problem. So I know 107 mass number is equal to 47 plus something. So what plus 47 gives me 107 for my neutrons? That is going to be 60 for my answer. So I need 60 neutrons. If I move to my next row, all I have is atomic number of 80 and number of neutrons is 120. But that's plenty of information to be able to get the rest of the info. I know that if I have atomic number of 80, my protons must be 80. I know if I have 80 protons, I can assume I have 80 electrons so that they cancel out and be neutral. I know that if I add my protons plus my neutrons together, 80 plus 120 gives me the mass number, which is 200. If I look, element 80 on the periodic table is actually mercury. So I'm going to write in mercury, and because it's an isotope, I'm going to put its mass number of 200 on there as well. Now that I've named it properly, I can also do its symbol. Mercury's symbol is Hg. I'm going to put the mass number on top of 200, and I'm going to put 80 on the bottom for its atomic number. But now I figured all that out. For this last two columns, I like this because look how close they are. Bromine 79 and bromine 80. So wow, they're the same element, but they have a different mass number. These are isotopes. So if I look at bromine on the periodic table, bromine are both atomic number of 35, which means they both have 35 protons, which means they both have 35 electrons. All right. What else is the same about them? They both have the same symbol, Br, but their mass numbers are different. take a look. Bromine 79 has a mass number of 79. Bromine 80 has a mass number of 80. So what's different about them is their number of neutrons. So 79 has to equal 35 plus what? That would be 44, because 44 plus 35 would give me 79 for a mass number. Now, for bromine 80, that's going to be different. It's going to be 45 neutrons, because 35 plus 45 is going to equal 80 for my mass number. So the only difference between bromine 79 and 80 is really the number of neutrons. And that's what we've been saying the whole time, that an isotope is the same exact element, same protons, just different number of neutrons. So let's finish this off. Bromine is 79 on top, bromine is 80 on top, but they both have 35 on the bottom for their symbol. All right. I think this leads us to our last question, which we've already explained. How can bromine have a mass number of 79 and a mass of 80? It's because they are isotopes, which means, and you can write this down, they have the same number of protons, but different number of neutrons. Well, my friends, I think that concludes our review of atomic structure. I hope you followed along and gathered some information. Don't be afraid to ask questions or jump on in for intervention time to get a little bit of help. I'd be happy to help you. Best of luck, science fan. Be well.